Hey everyone. So far, I've gone through and covered uh, quick start, tensors, dataset, and data loader transforms. So for past week, whenever I had time, I have gone through build the neural network chapter, and today we will dive a little bit more into this section of the code, and also specifically like this block of code here where we define the neural network class and what these mean. So let's jump right in. And again, just as a reminder, these are not like I'm not teaching you neural network in these videos. I'm sharing what I've learned so far using PyTorch documentation. So if you feel free to leave a comment correcting me or sharing whatever you are learning currently. Now let's dive right in. Pretty usual matplot label inline here to plot anything in this Google Colab. And we have import OS, torch neural network, data loader, dataset, and transforms. Then we have a device, a code that finds out what device we have available, and we assign whatever the available device is. So we check if CUDA is available. If not, then we just check what's available. So in this case, we have CPU. So let me just run that. Yep, we have CPU available and it just says CPU device. I did cover this about this CUDA in previous videos. So if you want to go and check that out. And then let's go into, I'll get to this line of code here. There's a reason why I wrote that. Now let's get right into defining this neural network class. So if we look at this class in the init method, so we're calling the super method first, and then we have this, I'm going to dive right into this. We'll cover this later on other videos. We have this self.linear ReLU stack. Rectified linear unit, and we have, before we create that stack, we're actually using neural network sequential to put all these linear ReLU and repetition of that. Basically we have three linear network and then two activation functions. So now we go back to this code I wrote and we'll find out what these are. So if we go to this sequential that we're using here, sorry, there's a bit of going back and forth on scrolling here. So nn.Sequential, what it is, now it's a container that takes all these modules will be added into order they are passed in the constructor, right? So hence the name sequential. And what basically it does is it takes the input to the neural network, it feeds to this network here, and whatever the output of that is, it feeds into this activation function, and whatever output function this output this activation function gives, it can feed into the next one. So it takes the input, passes the output onto whatever the next is in the stack. And here at the end we have output of 10, and that is the final output coming out of this sequential container, right? So now to look at this here, so we kind of established what sequential is. To look at what the nn.Linear is doing, we're going to go up here. So in any neural network, you're going to have two things, weights and biases, right? So if we look at the bias here, our bias is this tensor here, right? So we have, and if we just do length of our bias, that's 20, right? And if we, that's because we have 20 by 20 linear instance, right? And if we just go to weights, weight, and then you can see this, not the length, we want to print that. Right, so you can see we have 20 by 20 weights that are applied to each input. So this will be multiplied to the input, and then the biases get added to the input. You can see we have numbers here from -1 to +1, and these numbers are random at the moment. Initially, these numbers will always be random, and then as you do a forward pass and then you check the output to your target, which is, if it's a photo of a dog, you want to check, is it the photo of the dog? And if it's not, then you'd come backwards using backward pass or back propagation, in which we then find out, okay, how much do we change these weights, therefore we can get to the target, right? So it matches the output, and then we keep going back and forth. So as you can see, the initial number will always be random, and then as you do a back propagation, your numbers are start to become more informed, and then as you keep iterating over this cycle, your numbers have much more weight in them, hence the name weights, as you are making these prediction more accurate. So that's what's happening here. So we have, if we just look at this module linear here, right? So we have applies a linear transformation to the incoming data. So for example, if we have a tensor incoming, it will multiply that with the weight and add the bias, right? So that's basically all all it's doing, this linear nn.Linear method. And now we go to rectified linear unit. And I'll just open this ChatGPT answer here, which is pretty good. So ReLU is primarily used in hidden layers of a neural network for introducing non-linearity. How does it help us introduce non-linearity? So we can, using this function here, that is all ReLU is doing, right? So let's just quickly look at that function. So if I had to write that function in Python, it's really, I'm just going to write a def ReLU, and then we have input, and then all it's doing is return some max of 0 or the input, right? So now if you think about it, so what it's going to do is, let me just open up another prompt. So if we call ReLU with 5, what do we get? We get 5. But if we call ReLU with -5, we get 0. So this activation function is simply helping us to remove all these negative value from weight. So it helps us remove the linearity of this output here, and that's all ReLU method is doing, right? And then there are other activation like softmax method. We will get to that later on, how that works, and what that helps us achieve. So just to summarize, so far what I've learned is the sequential class helps you contain these linear instance of this linear networks, and then also the activation functions. And what it's doing for us basically is helping us pass the input through forward pass, and then use the activation functions to remove the negative numbers. So we just have 0 to 1. So anything from 0.00001 to 1, and then it's just basically repeating those. So this becomes our module to train, right? So we do back forward pass and then back propagation. So in the next video, we will go through the rest of the chapter. I will go through and I'll share what I've learned so far, the rest of the chapter. Hope you're gaining something from these videos, and if you do pick something up that I have learned incorrectly, Please feel free to comment and share, or comment if you're also learning neural network at the moment.